We're jumping straight into one of the most vibrant, dazzling, and honestly, utterly vital ecosystems on planet Earth. If you've ever pictured the ocean floor as just this vast, endless desert of flat sand in every direction, well, prepare to have that image completely shattered. Today in our explainer, we're exploring dynamic, three-dimensional metropolises that harbor an unbelievable concentration of biological wealth. We're talking about coral reefs. They are, quite literally, the underwater rainforests of our world. But before we get into the massive scale of these ecosystems, or the thousands of species that call them home, I want you to think about something truly mind-bending. How do tiny animals, creatures so incredibly small you'd barely even notice them in the palm of your hand, how do they manage to build massive geological structures that astronauts can actually see from outer space? I mean, it sounds like an impossible feat of science fiction, doesn't it? Yet it happens every single day. It's an absolute miracle of biology, an anomaly of scale that really sets the stage for everything we're going to unpack today.
Okay, let's dive into this. To truly appreciate the sweeping majesty of a massive coral reef, we actually have to meet the tiny architects first. You have to start small to understand the massive scale here.
So when you look at a vibrant reef, you aren't just looking at colorful rocks or, weird ocean plants. You're actually looking at sprawling colonies of tiny, soft-bodied animals called coral polyps. These polyps are nature's ultimate biological engineers. They literally pull dissolved salts out of the surrounding seawater and use them to secrete hard, protective exoskeletons made of calcium carbonate. Basically, imagine an animal 3D printing its own limestone armor. Layer by layer, generation after generation, as older polyps die and new ones build right on top of their skeletons, this calcium carbonate accumulates into the massive underwater structures we call reefs. It's an architectural achievement that vastly outpaces human engineering.
Now, when we zoom out from those microscopic polyps, the true genius of what they build becomes totally apparent. We routinely call these ecosystems the underwater rainforests, and honestly, that's a scientifically perfect metaphor. Just like the Amazon rainforest relies on towering trees to create a multi-layered environment, a canopy, an understory, a forest floor, coral reefs provide that exact same three-dimensional complexity beneath the waves. They build towering columns, deep crevices, intricate caves, and sprawling plateaus. This verticality transforms a flat, barren ocean floor into a multi-story high-rise full of endless nooks and crannies.
And this brilliantly illustrates the sheer density of life here. Because of all that complex structure, these environments provide shelter, food, and breeding grounds for just a dizzying array of creatures. But there's a catch to these spectacular underwater cities. They can't just grow anywhere. They require a very specific Goldilocks zone to thrive. See, inside the tissues of these coral polyps live microscopic algae called zooxanthellae. These algae photosynthesize and provide the coral with up to 90% of its food. Since this algae absolutely needs sunlight, coral reefs are found almost exclusively in the warm, shallow, incredibly clear waters of tropical oceans where the sun's rays can easily penetrate. To give you a concrete sense of exactly where this Goldilocks zone exists on our map, let's consider some monumental global locations. The Great Barrier Reef in Australia is the undisputed giant. It's not just one reef, actually. It's a network of thousands of individual reefs stretching over 1,400 miles. It's literally so vast, it generates its own weather patterns. But you'll also have incredibly vital ecological anchors in places like the Lakshadweep and Andaman Islands in India. These global hotspots act as the biological lifeblood of their respective oceanic regions, transforming otherwise empty waters into thriving hubs of marine activity. Thanks to that perfect geographical positioning and structural complexity, these reefs become chaotic, bustling metropolises. The sheer volume and variety of life attracted to these calcium carbonate fortresses is staggering. On any given day on a healthy reef, you might see majestic sea turtles gliding through the current, apex predators like reef sharks patrolling the perimeter, and vivid, intricately patterned clownfish darting between the stinging tentacles of anemones. There are even designated cleaning stations, literally places where large fish line up to have tiny shrimp pick parasites off their scales. It's a fully functioning underwater society. Now, I want you to just pause for a second and let this incredibly powerful piece of data sink in. 25%. An entire quarter of all marine species on planet Earth call coral reefs their home. Think about the vast, seemingly endless, deep expanse of our global oceans. Okay, now realize that coral reefs cover less than 1% of the ocean floor, less than 1% of the space, yet they hold 25% of the life. If these ecosystems collapse, it's essentially a catastrophic eviction notice for a quarter of the ocean's population. It is a staggering concentration of biological wealth that we simply cannot afford to lose.
So why do reefs matter to us? At this point, it's really easy to view the ocean as an isolated world, a beautiful natural wonder that exists entirely separate from our daily land-based lives. But the reality is far more intertwined. We need to pivot our focus to human relevance now, because what happens beneath the waves doesn't stay there.
So the crucial point is this: we rely on reefs for some absolutely critical heavy lifting. First off, their rugged structures act as massive natural breakwaters, absorbing up to 97% of incoming wave energy. This protects our coastlines from fierce storms, preventing catastrophic erosion and literally saving coastal cities. Second, they act as the ultimate nurseries, supporting both commercial and local fisheries that provide essential protein to roughly 1 billion people worldwide. And finally, beyond the massive economic engine of tourism, reefs are essentially the ocean's pharmacy. Chemical compounds found in reef sponges and organisms are currently being used in groundbreaking treatments for cardiovascular diseases, ulcers, and even certain types of cancer.
Yet, for all their massive scale, their rock-hard calcium structures, and their critical importance to human survival, these architectural wonders are shockingly fragile. We have to address a much more precarious reality now. These vital ecosystems, the bustling underwater rainforests we've just explored, are facing a fragile, incredibly uncertain future. They are currently buckling under the intense pressure of several severe, human-driven threats that are converging all at once. The most immediate and devastating of these is coral bleaching, which is driven by a rapidly warming climate. When water temperatures spike, the stressed polyps literally evict those colorful, food-producing algae we talked about earlier. Without the algae, the coral turns stark white and slowly starves to death. Compounding this is severe pollution, things like agricultural runoff and plastics that smother the polyps and block the sunlight. Then add the immense pressure of overfishing, which removes the crucial grazing fish that keeps seaweed from overgrowing and suffocating the reef. It's a perilous, multifaceted onslaught that is breaking down the ocean's greatest cities much faster than they can rebuild.
This interconnected cascade of threats brings us to an ultimate, undeniable warning. Save the reefs, save the oceans. This isn't just an emotional slogan, it is the fundamental mathematical equation of marine biology. The reef is the biological engine of the broader sea. If the nurseries disappear, the massive pelagic fish populations out in the deep blue will crash. The entire food web unravels from the bottom up. The fate of the coral reefs and the fate of the entire marine world are deeply, inextricably bound together. You cannot have a healthy, functioning ocean if its most vital habitats are turned to rubble.
Which leaves us with one final, incredibly important thought to reflect on as we wrap up our explainer on this topic. Look at the immense balance of life. The 25% of species relying on these structures, and the billions of humans relying on those coastlines. If we lose the reefs, do we lose the oceans?